Assalamu alaikum. How are you, student? Hopefully you are all fine. So today I'm going to start to solve a paper from AS level chemistry for you. This paper is, you can see the code 9701/22 and is October November 2022. Okay, so let's proceed. So question number one, it says that species such as ammonium ion, carbonate ion, and phosphate ion are examples of molecular ions. We can also say these are the complex ion or the compound ions. Even we can use the word radicals for these ions. Okay, so these are radical or complex ion or the compound, or you can say the example of molecular ions. Now, ionic and covalent bonds both involve an electrostatic attraction between different species. Identify the species that are electrostatically attracted to one another in an ionic bond. So, definitely we are going to define, actually we can say the examiner is asking define ionic bond, but as this is from AS level chemistry, advanced level chemistry, so no direct question that define ionic bond, asking the same question in a different style. So what we have to say, just define ionic bond. What is ionic bond? The attraction between oppositely charged ions. So we can say between oppositely charged ions. Next, a covalent bond. So again, you have to define covalent bond. How we can define? We can again say it is electrostatic attraction, but now this time between the nuclei, between the nuclei of non-metal atom, non-metal atoms, and shared pair of electrons, and shared pair of electrons. So you may we can say reduce the words, but the theme remains the same. So the ionic bond is actually between oppositely charged ions, whereas the covalent bond is between the nuclei and the shared pair of electron. So in, you can see in both of these situations there is electrostatic attraction. So please remember this in mind, whether you are and when you are going to solve any paper. Actually this will give you an idea how examiner can ask questions. Okay, so you can expect different questions in your upcoming paper exams or your practice exams. You can observe same type of the question with different words, different meanings, but the theme remains the same. Okay, so the B part, complete table 1.1 to show the total number of protons and electrons in the molecular ion ammonium, carbonate, and phosphate ions. So first of all, he says we have to find the ammonium ion, molecular ion. This is the complex or molecular ion, and we have to find the number of protons. So as we can see, there is nitrogen. There are total 7 protons in nitrogen atom, and we have 4 hydrogen atoms, whereas total number of protons in one of the hydrogen is 1. So if we do calculation, simple calculation, so we can say there are total 11 protons. And how to find total electrons? In a similar way, that we have 7 electrons from nitrogen, 1 electron from each hydrogen, and there are 4 hydrogen atoms, so again there is 11. But you can easily observe the plus sign, which indicates the loss of 1 electron. So what should be the total number of electrons now? We can say now the total number of electrons are 10. In the carbonate, we have to calculate in the similar way. We have 1 carbon atom which has 6 protons, plus we have 3 oxygen atom. Each oxygen atom has 8 protons in its atom. So what we can say, we have to just add 3 8s are 24 plus 6, so we can say there are total 30 protons. But on the other hand, if we are going to calculate the number of electrons, what we can say, total electrons and protons are always same, but the negative charge on this complex ion indicates they gain 2 extra electrons. Okay, so I'm going to add 2 more electrons due to the presence of this 2 negative charge on it. So what will bring, it will give us 32. So the total number of electrons in carbonate ions are 32. In case of the phosphate, we have phosphorus, which has total 15 proton, as the atomic number of phosphorus is 15, plus there are 4 oxygen atoms. Each oxygen atom has 8 protons. So if we calculate, 4 8s are, I'm going to use my calculator, this will hold on. So 4 times 8 plus 15, 4 times 8 plus 15, so it's 47. Now to find the electrons, we have to do the same operation, like the proton and electrons are same, but we can see 3 negative mean there are 3 more electrons, so I'm going to add 3 more, so the total number of electron will be 50 in this situation. So hopefully you understand how I calculated these electrons. Okay, and if you have any question, any query, you can see that these questions you can understand, but you have some difficulties, so please comment. I will more happy to answer your questions. Okay, so in the C part, you can see ammonium ion. He says that this is Bronsted-Lowry acid. So the question is, define Bronsted-Lowry acid. So my advice for the preparation strategy, you have to take your notebook and write the heading there, the exam definitions, and write down each and every definition whenever you are solving a paper, solving an exam, and you have some definitions. So please write it down, and then try to memorize all of those definitions, because these are exam definitions and they are always in your exams. Okay, so you have to prepare all these definitions. The shortest and the simplest definition is that proton donors. Bronsted-Lowry acids are proton donors. So we can simply say proton donors, or Bronsted-Lowry acids are proton donors. Next, when ammonium ion is heated with sodium hydroxide aqueous, a pungent smelling gas. This is ammonia actually. What is this? This is ammonia gas. Then write an equation for this reaction. So this is the hint for the equation, gas released. I write it the formula. Now you just have to follow the instruction. He says that they are reacted together. So what we have ammonium ion aqueous plus we have sodium hydroxide NaOH aqueous. When they are going to react with each other, we need heat, as is clearly mentioned that heated. Okay, so these are the reactants already advised in this statement. Now we have to write the products. So what we got this ammonium ion releases one of the hydrogen, as we also define this ammonium ion is a Bronsted-Lowry acid. So the acid release hydrogen ion protons. Those protons will combine with this hydroxide ion, making water, and the physical state of water should be liquid. Plus, as I said, one of the hydrogen is removed, so now this ammonium ion turned into NH3, ammonia gas. Okay, ammonia gas. Rest, we can see sodium, which is a spectator ion. We are going to write it as it is, sodium ion. It stays in the form in aqueous solution. So as this is sodium and it's a spectator ion, you may remove this if you wish. Then your equation should be like this: NH4 aqueous, ammonium ion aqueous, reacting with the hydroxide ions aqueous. I remove the sodium ion because this is spectator ion. Okay, so when I remove this, what are the product we got? Water and ammonia. Hopefully you understand why I did this. So both are acceptable. If you write the equation in this format or if you write the equation in this format, both are acceptable and correct. Proceeding. In this part, examiner says the nitrogen atom in ammonium ion is sp3 hybridized. sp3 means one of these s and three of the p orbitals are involved in bonding. Then sp3 orbitals form from mixing one. So this is the definition again. So you're lucky enough that examiner also defined what is sp3. Then sketch the shapes of 2s and 2px. Remember, examiner clearly mentioned the orientation like x. Okay, so you have to keep it in mind. Now we know that the shape of the s orbital is spherical. So you have to draw a sphere. Okay, like this. Next, p. So you can see three orientations, three axes, x, y, and z. But it is clearly mentioned that we have to show on the x-axis. The shape of the p orbital is like a dumbbell. Okay, either in this way or in this way. So these are just orientation. Shape remains the same. And as it is clearly advised that we have to show on x-axis, so we are going to show only the loops or the dumbbell shape on the x-axis only. Next question. There are many natural occurring hydrated compounds that contain the anion phosphate ion. Name the anion phosphate. So as I mentioned and as I named, so it is phosphate. And as it is ion, so you have to mention ion as well. Next thing, if you are going to write it more accurately, you have to figure it out that what is the oxidation state of phosphorus in this ion. So the oxidation state of phosphorus, as we learned that whenever we are working on the oxidation state of a complex ion, on a molecular ion, what we have to do, phosphorus is unknown. We have 4 oxygen atoms. Each of the oxygen atom has the oxidation state of -2, and the complex ion has the charge that will becomes the overall oxidation state of the ion. Now if we're going to solve this, what we will get? We'll get +5. So this shows that the oxidation state of phosphorus in this complex ion is +5. So if we write the name like phosphate 5, that will be more perfect. Phosphate 5 ion. So this will be more perfect. And if you just write it phosphate ion, it will be good as well. So you will get the marks. Proceeding. Struvite is a soft hydrated mineral with the molecular mass of 245.3. The anhydrous, so remember, this is the mass of hydrated one. Now we are talking about the anhydrous. Anhydrous mean without water, whereas hydrated mean with water. So keep that information, this information in your mind. Then he says the anhydrous form of the mineral has the formula ammonium magnesium phosphate. Ammonium magnesium phosphate. These type of the salts are called as double ion salt. So this contains 2 cations, 1 anion. Okay, so double salt. Then calculate the number of molecules of water of crystallization in struvite. Give your answer to the nearest integer. Mean we have to write down in a whole number value. Whatever we got the answer, we must have to write it in the whole number value, whole number. Now what we have to do? We just have to find mass of water. How? Mass of water. How we have to figure it out? By just subtracting the mass of hydrated sample, mass of hydrated sample, negative or subtracting from this mass of anhydrous sample. This will give us the mass of water, mass of anhydrous sample. So we know that it is given the mass of hydrated one is 245.3. Negative, here we have to find. This is the task we have to find, and we have to figure it out. What is the MR of this part? So in this part you can easily see we have one nitrogen atom. The atomic mass of nitrogen is 14, plus we have one magnesium atom, and the atomic mass of magnesium is 24.3. You have to use your data booklet, and in this case, as this is a recent paper, you are not provided with the data booklet, but definitely with the periodic table. So you definitely have a periodic table, copy of periodic table at the end of the exam paper, so you have to use that one. Okay, so in this case I'm using, or I'm saying, the data booklet, so I am actually using the periodic table as a data booklet. So one time 24.3, which is the atomic mass of magnesium. Now we have one phosphorus. The atomic mass of phosphorus is 31, plus we have 4 oxygen atoms, and the atomic mass of oxygen is 16. So let me calculate the value here. 14 plus 24.3 plus 31 plus 4 times 16. So the final answer I got is 133 point, sorry, what I forgot is the hydrogen. I didn't calculate the mass, so we have to add 1 is the atomic mass of hydrogen, and we have 4 hydrogen atoms. So plus 4, the final answer, this will give us 137.3. So I'm going to write it over here, 137.3. When I subtract what value we got, 245.3 minus 137.3, so the final answer is 108. So now this is the mass, and U, as it is clear, number of molecules, the number of molecules is also moles, so actually we are going to find the moles of water. How? Moles of anything could be calculated by dividing the given mass with the molar mass. So molar mass means MR of a water molecule is 18. If we divide this, see the answer I got, divided by 18, which is the molecular mass of water, so perfectly I got 6, which is the whole number value. So we are not going to round it off, okay, nearest integer. So we're not going to round it off, as we got the whole number value already, so it's 6. Proceeding. Okay, so the next question is look like from organic. So he says that hydroxide ion aqueous react with 2-bromo 2-methyl propane in an SN1 reaction. So SN1 could be done or undergo what type of halogenalkanes? The tertiary one. So it definitely means this 2-bromo 2-methyl propane is a tertiary halogenoalkane. Then he says the molecular ion of this tertiary carbocation forms as intermediate in this reaction. You can see easily here, this is the intermediate, this one, trimethyl carbon. Draw the mechanism for SN1 reaction of hydroxide ion. So in SN1 mechanism, we are going to use only one species in the initial step, which is this lowest step. So I'm going to draw 2-bromo 2-methyl propane. So here I'm going to write methyl, here I'm going to write methyl as well, and methyl part. Okay, so here deliberately I am drawing little lengthier line. Remember, it doesn't matter, as we are just going to show the mechanism, and the bond length remains almost, we have to show similar. This is just representation. It doesn't matter whether I'm going to use the lengthier line or the shortest one. But now we know that bromine is electronegative atom, so it will have, or it will bear partial negative charge. The carbon has partial positive charge. So as this forms a more stable carbocation, which is the tertiary one, so there is a chance that it could remove, or it could withdraw its electrons from the bond, making the bromide ion. Making what? A bromide ion. So we are going to show here the bromide ion right here. Plus, Now, as the hydroxide ions are attacking, so now we are going to show the hydroxide ion like this, OH negative, with one extra electron pair, and from the center of this electron pair we are going to show a curly arrow and attack on this carbon positive charge carbocation. Okay, as a result, what happened, we found or we formed a new molecule which is C. Now the OH bond replacing the bromide ion, so that is why it is nucleophilic substitution. One nucleophile, the stronger one, is replacing the another nucleophile bromide, which is the weaker one. So I got CH3 over here, over here. So this could be the final product. Now try to understand how you got these 3 marks. Number 1, remember, in the whole mechanism, wherever you have to show the partial charges and the complete charges, you will get 1 mark. Okay, the next mark is for the curly arrow. Whenever and wherever you are going to use the curly arrow, like in this mechanism, we just use the curly arrows twice. So if you missed any one of these, then you will not be able to get that mark. The third mark, which is the final mark, is related to the showing of lone pair of electron, and sometimes it is also related to the species form. Okay, so if this is not correct, you will not be able to get that mark. So be aware and properly know that what is the breakdown of these marks. Then you will easily practice and you will focus how to get all these marks. Next part, 2-bromo-2-methylpropane is a tertiary bromoalkane, as we discussed earlier. Then he says that define tertiary bromoalkane. So we can say a type of haloalkane or bromoalkane in which carbon atom bonded with bromine is further bonded with 3 carbon containing species. 3 carbon containing species. Or even you can say that there is no hydrogen attached to the carbon which is bonded to bromine halogen. That is called as the tertiary one. Okay. Next, third part, the organic compound M forms when 2-bromo-2-methylpropane, which was the tertiary, is heated with ethanolic hydroxide. Mean it is not only hydroxide, it could be sodium or potassium hydroxide or any soluble alkali. Now this is the situation that when we are going ethanolic, what happens? Elimination reaction takes place. Elimination reaction takes place. What is elimination? The halogen that is bonded to the carbon atom is removed, and from the adjacent carbon atom hydrogen is removed. Like in this case, as we have this type of the halogen alkane, tertiary one. So you can see that we have a very similar, we can say symmetry in this molecule. The bromine is going to be removed from this carbon atom. Then either we are going to remove hydrogen from this, or from this, or from this. In all of these cases, what we get, one of the hydrogen is if removed from here, like I'm going to draw CH3C, bromine is removed from here, and hydrogen is removed from this carbon atom, so we will get CH2 and then CH3. So in this case, what we are going to get, this is carbon 1, this should be carbon 2, this should be carbon 3, or that should be carbon 3. Now this is the branch. So in this case, the name we get will be 2-methylpropene. And in either case, we get the same molecule. If we are going to remove the hydrogen from this carbon atom, then you can see what we got. CH2, one of the hydrogen is removed from this carbon, the double bond will appear over here. These methyl groups and this methyl group remains the same. So in this case, you can easily say again we are getting the same molecule. or, and this will be the case if we remove the hydrogen from this one. Okay, so only orientation changes and double bond just shifted to this position, but the molecule remains the same. So we examiner can ask you a question, may ask you a question that during this type of situation, how many different compounds, how many different products we got? So we can say we get only one product. Okay, as furthermore this molecule is not going to show geometrical isomerism. If there is a possibility, then we examiner also or can may ask you a question, how many different isomers we got. So keep that in mind. So this question is complete. Okay, so we will continue with the next question inshallah in the next video. Take care by this, and if you have any question, feel free to ask in the comment, and I shared my number as well, so you can contact me on my WhatsApp as well. Take care. Bye bye.